So FRAPPY number 6 just gives us two functions. We've got f of x and g of x. F of x is defined by an integral, so that's kind of interesting. And then g of x is actually defined by f of x, as f of sine of x. So part A asks us to find the derivative of both of these functions. When we're finding the derivative of f of x, we've done something similar to this before, where we're finding the derivative of an integral and it's from a number to x, but this is actually from a number to 3x, so it's slightly different. The only difference here is that when we take that derivative of the integral, I am going to plug in the whole 3x for t, but then because it was a 3x and not just x, I also have to multiply by the derivative of x. Or derivative of 3x. I'm not going to get super into that because it doesn't happen a ton, but if you see that derivative of an integral, you do need to also plug that in and then also multiply it by the derivative of 3x. So then I just went ahead and simplified that part. Not necessary, but I just felt like doing it. For the derivative of g of x, I'm looking at using the chain rule since I had f of sine of x. So the first part of that chain rule would be the derivative of the outside, so f prime of sine of x, but then times the derivative of the inside, so times cosine, and then just simplifying this f prime of sine of x, since we know that f prime is up here, I can go ahead and plug in my sine of x into the derivative for f prime, just to make it to where it's all in terms of x. Part B wants us to write a tangent line for the graph of g of x at x equals pi. So we know that if we're writing a tangent line, we need a point and then also the slope at that point. So my first step, I'm going to go ahead and find g of pi so that I can figure out what that point is. So remember that g was defined by f of sine of x, so we've got f of sine of pi, which the sine of pi is just 0, so that means we're evaluating f of 0, and then remember f is an integral, so we've got from 0 to 0 when we plug in that x being 0 for 3 times 0. And we know that any integral from a number to that same number is no area under the curve, so our point is just pi 0. If this was complicated, by the way, I could leave this as gross as I want to, so even if they told me the integral from 0 to 11 of this radical, you could even leave it like that. I wouldn't simplify anything that you don't have to. So don't be afraid to leave things kind of gross there. The other part of my tangent line is figuring out the slope when x is pi. So I'm going to my g prime, which I had calculated up here. So I'm plugging in pi. I accidentally plugged in 0 first. I'm plugging in pi for both of these. My sine of pi we found up here was 0. Cosine of pi is going to be a -1. So when I replace those things, that whole part ends up being 0. Taking the square root of 4, I get 3 times 2 there. And it's going to be -6. So then my last step, putting this all into the equation for a tangent line, I've got my y minus my y value equals my slope, x minus the x value. And again, you can clean things up there if you want to, but there's no need to, so I wouldn't waste time simplifying. Part C wants us to write but not evaluate an integral expression that represents the max value of g on the interval from 0 to pi. So first of all, we actually do have to find the x value, but it's saying for us to write an integral to represent the y, that would be the max. So first, just in finding the x value, I need to explore endpoints or critical values to figure out what x value is going to be the absolute max. When I test the endpoints, they both end up being 0. And remember that g of x is defined by f of sine of x. So if we have that f of sine of 0, we're looking at that integral from 0 to 0. Same thing happens with sine of pi. We're looking at that integral from 0 to 0. So either of those values end up being 0. So this is a pretty good argument for our critical value being the max. So looking at critical values, I'm looking at where g prime of x equals 0. And this is a little tricky, but if we're trying to see where g prime of x, oh, I need to go a little further, don't I? If I'm trying to figure out where g prime of x is going to equal 0, even if sine squared x equals 0, that's still not going to take care of all of this. So in order for my g prime of x to be 0, that means that cosine would have to be 0, because it's going to have to multiply by everything else and wipe it out. So I'm going to make a little jump here to say that my g prime of x equals 0 when cosine of x equals 0, which happens at pi over 2, since we're only from 0 to pi. Okay, so now that we know where it's happening, so this has to be our max here at pi over 2. Now we know where it's happening, we're plugging that back in to find that integral approximation for that max. So we've got g of pi over 2, that would be where the max is happening, the y value, but that's defined by f of sine of pi over 2. Sine of pi over 2 is just 1, so now we've got f of 1. And then if we plug in 1 into our f, we're looking at from the integral from 0 to 3 of that whole thing that f was defined by. So this is the integral that they were looking for that would represent the max value, or g of pi over 2.